All right, so let's put some more time into Nvidia. I've got about 20 minutes here. I should be able to knock off, hopefully, that whole third section. So we'll go to my YouTube account. There we go. And then, we'll go to the channel page. All right, so we're on part 9. It's time to go to do
All
another
right,
part
welcome
here.
back. So I've got a few minutes here, maybe.
All right, so the next section is vGPU virtualization for IT. This should take about 3 minutes, so I'll put 3 minutes on the clock. All right, so future-proof your infrastructure. Simplified management of virtualized data centers. Management and monitoring. Live migration of GPU accelerated VMs gives you continuous uptime and proactive management abilities without negatively impacting users or losing data. Business continuity and workload balancing. Increase utilization of data center resources by leveraging a unified virtual GPU accelerated infrastructure to run mixed VDI and compute workloads. Resource sharing and improved utilization. Divide GPU resources and share them across multiple VMs, or allocate multiple GPUs to a single VM to power the most demanding workloads. And then bare metal performance. Get performance that's nearly indistinguishable from a non-virtualized environment with flexible scheduling options. Take a peek under the hood. In a virtualized environment that's powered by Nvidia virtual GPUs, the Nvidia virtual GPU vGPU software is installed at the virtualization layer along with the hypervisor. This software creates virtual GPUs that let every virtual machine VM share the physical GPU installed on the server. For more demanding workflows, a single VM can harness the power of multiple physical GPUs. Our software includes a graphics or compute driver for every VM. Since work that was typically done by the GPU is offloaded to by the CPU is now offloaded to the GPU, the user has a much better experience. Demanding engineering and creative applications, as well as compute-intensive workloads like AI and data science, can be supported in a virtualized and cloud environment. So management and networking, end-to-end visibility. We've got apps. We've got NVIDIA graphics driver or NVIDIA RTX enterprise driver, vGPUs, NVIDIA virtualization software, hypervisor, NVIDIA GPU, and server. Okay, so start here for guidance on how to deploy NVIDIA virtual GPU technology, access tips and best practices for sizing your environment, or contact NVIDIA Enterprise Support. So these are how-to videos. This is NVIDIA Enterprise. So hey, I think this is the first one where I finished it within the time frame. So that's good. Now, granted, there's an entire white paper listed that would take 2-3 hours to read that you might have to read to pass the test, but I allocated the 3 minutes that it said. So so I think that's it for this one. So good news. Moving on to the next one. Okay, so this one's interesting because the reading time is 2 minutes. So I don't know what part of this is fair game to read. So this is NVIDIA Data Center GPU Manager DCGM overview. So if there's an overview, I should just stick to the overview. It looks like, yeah. So here it is, DCGM. So we've got an overview when it comes to the DGX best practices, but specifically for DGCM, it looks like this is the overview here. So it's going to be it's going to be up until here, and then the next section is using CTOP for monitoring. So this should take just a few minutes to read. Just 2 minutes to read. All right, so NVIDIA Data Center GPU Manager, DCGM, simplifies GPU administration in the data center. It improves resource reliability and uptime, automates administrative tasks, and helps drive overall infrastructure efficiency. It can perform the following tasks with very low overhead on the appliance: active health monitoring, diagnostics, system validation, policies, power and clock management, group configuration, and accounting. The DCGM toolkit comes with a user guide that explains how to use the command line tool called DCGMI, as well as an API guide. There is no GUI with DCGM. In addition to the command line tool, DCGM also comes with headers and libraries for writing your own tools in Python or C. Rather than treat each GPU as a separate instance, DCGM allows you to group them and then apply policies or tuning options to the group. This also includes being able to run diagnostics on the group. There are several best practices for using DCGM with the DGX appliances. The first is that the command line tool can run diagnostics on the GPUs. You could create a simple cron job on the DGX to check the GPUs and store the results either into a simple flat file or into a simple database. There are 3 levels of diagnostics that can be run, starting with level 1. Level 1 runs in just a few seconds. Level 3 takes about 4 minutes to run. An example of the output from running level 3 diagnostic is below. So levels of diagnostic, we can see -R stands for the level apparently instead of -L. So that's it. So let's put some extra time on the clock. And then we can see the diagnostic and the results. So the diagnostic, we have deployment, hardware integration, and performance diagnostics. And the result is that everything passed except for targeted power. There was a warning there. It is fairly easy to parse this output looking for error in the output. You can easily send an email or raise some other alert if an error is discovered. A second best practice for utilizing DCGM is if you have a resource manager. In other words, a job scheduler installed. Before the user's job is run, the resource manager can usually perform what is termed a prologue. That is any system calls before the user's job is executed. This is a good place to run a quick diagnostic and also to use DCGM to start gathering statistics on the job. Below is an example of statistics gathering for a particular job. So DCGMI is stats-job, demo job-v-g2. So we successfully retrieved the statistics for this particular job, demo job. And this looks a lot like PyATS. It's kind of cool. So we've got for the GPU ID 0, we've got execution stats, performance stats, event stats, slowdown stats, and you can do this sort of thing with PyATS, which is kind of cool. All right, so we got just a few more to go here. When the user's job is complete, the resource manager can run something called an epilogue. This is a place where the system can run some system calls for doing such things as cleaning up the environment or summarizing the results of the run, including the GPU stats as from the above command. Consult the user's guide to learn more about stats with DCGM. If you create a set of prologue and epilogue scripts that run diagnostics, you might want to consider storing the results in a flat file or a simple database. This allows you to keep a history of the diagnostics of the GPUs so you can pinpoint any issues if there are any. A third way to effectively use DCGM is to combine it with a parallel shell tool such as PDSH. With a parallel shell, you can run the same command across all of the nodes in a cluster or a specific subset of nodes. You can use it to run DCGMI to run statistics across several DGX appliances or a combination of DGX appliances and non-GPU enabled systems. You can easily capture this output and store it in a flat file or database. Then you can parse the output and create warnings or emails based on the output. Having all of this diagnostic output is also an excellent source of information for creating reports regarding such topics as utilization. For more information about DGM, we can read beyond just the overview. But this is it, the overview. So we're twice over the time, which is more than twice over the time, which is not bad for me. So let's move on to the next part. All right, so this is another 2-minute one that will probably take a bit more than that, but okay. All right, but that will be the end of the infrastructure section. Nvidia DCGM, manage and monitor GPUs in cluster environments. Nvidia Data Center GPU Manager DCGM is a suite of tools for managing and monitoring Nvidia data center GPUs in cluster environments. It includes active health monitoring, comprehensive diagnostics, system alerts, and governance policies, including power and clock management. It can be used standalone by infrastructure teams and easily integrates into cluster management tools, resource scheduling, and monitoring products from Nvidia partners. DCGM simplifies GPU administration in the data center, improves resource reliability and uptime, automates administrative tasks, and helps drive overall infrastructure efficiency. DCGM supports Linux operating systems on the x86-64 ARM and Power PPC64LE platforms. The installer packages include libraries, binaries, NVIDIA Validation Suite, NVVS, and source examples for using the API, C, Python, and Go. DCGM also integrates into the Kubernetes ecosystem using DCGM Exporter to provide rich GPU telemetry in containerized environments. DCGM is now open source. Check us out on GitHub. So the benefits of DCGM, which we remember are NVIDIA Data Center GPU Manager, are GPU diagnostics and system validation. Effectively identify failures, performance degradations, power inefficiencies, and the root causes. Another benefit is GPU telemetry. Gather a rich set of GPU telemetry to explain job behavior, identifying opportunities to drive utilization and efficiencies, and determining root causes of potential application performance issues. All right, so we need some extra time on the clock. There we go. Active GPU health monitoring. Use low overhead, non-invasive health monitoring while jobs are running without impact to application behavior and performance. And then integration with management ecosystem. Easily deploy a DCGM-based monitoring solution in a Kubernetes cluster environment. Out-of-the-box integration with various ISV solutions such as Bright Cluster Manager, IBM Spectrum LSF, and open source tools such as Prometheus Collect-D. So we can learn more here. And now we have instructions for installing the latest DCGM. And then we have the archived releases, but I'm over time, so I think that's probably not necessary to go over. All right, so maybe it's recommended to use the latest driver, but that should be self-evident, right? So okay, so that's it for this. I'm kind of tempted just to stop it there because it's such a clean place to go, but I do have quite a bit more time this morning. You know what? I think I am going to stop it there. So that's it for this video. Thanks for watching. See you in the next one.